So in Fourier transform, we have solved few problems. Fourier transform of del of t e power minus a t ut, how to draw the magnitude spectrum, phase spectrum, and inverse Fourier transform of del of omega minus omega naught. From that, we have derived some other formula, that is Fourier transform of 1. What is the result? Fourier transform of e power j omega t. What is the result? Fourier transform of e power minus j omega t, followed by cos omega naught t, and how to draw the magnitude spectrum for cos omega naught t from x of j omega, and how to draw the phase spectrum sin omega naught t from the result x of j omega, how to draw magnitude spectrum and how to draw phase spectrum, and some standard signal. Okay, in today class will solve two more problems. These are all some standard problems. Many times, frequently, these problems will be repeating in Fourier transform. One is signum function. So if you directly use this integration limit, then you will get infinite result. Okay, even though the signal is bounded signal only. So for that reason, we have to modify the signum function in this format. Just I'm adding e power minus a modulus t, limit a tends to 0. Okay. So modulus t plus t for positive value of t, modulus t becomes minus t for negative value of t, and then do the integration. Yesterday, and at one step, particularly minus infinite to 0. So wherever while solving the problem, if you are getting integration minus infinite to 0, you try to change this integration limit from 0 to infinite. So I hope you know already how to change this. Anyway, I have written note here. This step I wanted to change from 0 to infinite. Summation, no problem. Summation 0 to infinite, infinite to 0, it doesn't matter. But integration, whenever if you are changing your limit, then you have to substitute minus in front of your answer. Because upper limit minus lower limit as per integration. Now, if you are changing the limit, then minus of lower limit minus upper limit. That is the concept. But here, minus infinite 0. So I want to make this 0 to infinite. First, first replace all t by minus t. T equal to minus infinite, t equal to 0. This is the actual meaning, correct? So now replace all t by minus t. So you are replacing minus t equal to minus infinite, minus t equal to 0. So that becomes t equal to infinite. So that becomes t equal to 0. Okay. First step, replace all t by minus t. Then you will get infinite to 0, e power minus at, e power j omega t. This t also minus t. So dt, you will get one more minus. So this minus will be cancelled. Now you got the result integration infinite to 0. But I need the format 0 to infinite. Now change your integration limit 0 to infinite. For that, you have to put 1 minus in front of this integration. Okay. So finally, this is my answer. My yesterday problem. Okay. So I have changed this particular step into 0 to infinite minus e power minus at. So this we cannot write directly in your rough work. You have to do in this way. Replace t by minus t and then interchange your limit. Okay. And solve for your final answer. Right. So Fourier transform of signum function. This is the result for Fourier transform of signum function. Right. Next, how to solve Fourier transform for u of t. Next. Subdivision B in the same problem. X of t equal to u of t. Find the Fourier transform. Okay. What is the sketch for u of t first? Minus infinite to 0, 0. 0 to infinite, the magnitude is 1. Okay. So I'm going to write this u of t signal in terms of signum function. What is signum function? This is signum function. minus infinite to 0, 0, 0 to infinite magnitude 1. This is actual signum function. If I scale this signum function magnitude by 0.5, 0.5 signum function. Okay, this magnitude is 0.5. Sorry. Signum function 0 to infinite plus 1 minus infinite to 0 minus 1. Okay. So 0.5 signum 5t, then your magnitude would become 0.5. See, 0 to infinite 1 minus infinite to 0 minus 1. So this is signum function. So if the magnitudes are scaled by 0.5, then this is 0.5 and this is minus 0.5. Okay. So from this signal, I want u of t. For that purpose, what I'm going to do, I'm going to add a DC value of 0.5. Going to add a DC value of 0.5. Now add these two signals, signal 1 plus signal 2. Add these two signals. This is magnitude with 0.5. So negative side, minus 0.5 plus 0.5, you will get 0. Positive side, 0.5, 0.5, you will get 1. You will get 1. So in the problem, if they are asking to find the Fourier transform of u of t, please remember what is the result for Fourier transform of signum function, 2 divided by j omega. Okay, this is some standard formula. Right. Now u of t can be written as 0.5 signum function plus 0.5. This 0.5 is a DC value. So I'm going to write now my x of t, that is u of t. The u of t is equal to 1 by 2, this signal. 1 by 2 plus 1 by 2 of signum function, or 0.5 plus 0.5 of signum function. Okay, first rewrite your u of t in terms of signum function plus some constant value. If you add these two, you will get ut. Now apply the Fourier transform. Fourier transform of x of t. So Fourier transform of 1 by 2 plus Fourier transform of 1 by 2 signum function. Okay. So x of j omega equal to Fourier transform of 1 by 2. 1 by 2 dot is a constant. So you assume 1 by 2 dot 1. So already we derived Fourier transform of 1 is 2 pi del of omega. 2 pi del of omega. Okay. Plus this 1 by 2 is a constant. Fourier transform of signum function. The result is 2 divided by j omega. Okay. So this is your final answer. 2 2 will be cancelled. 2 2 will be cancelled. So Fourier transform of u of t is equal to pi del of omega plus 1 divided by j omega. This is the result. Okay. So signum function u of t. Please remember, don't apply your signal integration limit directly. Signum function also rewritten in some other format. U of t also written in terms of signum function. Then you apply the Fourier transform. Use the formula of Fourier transform. Then substitute. Okay. I'll write down here. Fourier transform of 1. 2 pi del of omega. Yesterday class we have solved. Fourier transform of signum function. The result is 2 by j omega. Okay, and then substitute and solve, you will get the final answer. Right. Next problem. Find the Fourier transform of x of t equal to e power minus 3t into u of t plus 2 minus u of t minus 3. Find the Fourier transform for this signal. E power minus 3t. It's a decreasing exponential only, so no problem. If it is e power 3t, then your integration limit would be infinite. Okay, it's not absolutely integrable. So this we can find the Fourier transform for this signal. What is the formula for Fourier transform of a continuous time signal, particularly a periodic signal? Okay. For periodic signal, what is the formula for Fourier transform? We will discuss later. Anyway, sin t cos t, we have solved Fourier transform using some formula. Okay. Other than this, some periodic signal sketch is given how to solve Fourier transform, that we will discuss later. Okay. We have to derive one more formula. In general, Fourier transform of a continuous time signal x of j omega equal to minus infinite to infinite x of t e power minus j omega t dot dt. For this particular signal, what is the integration limit? That we have to find out first. How to sketch u of t plus 2? This is the sketch for u of t plus 2, right? U of t signal started in advance by 2 unit of time. And what is the signal sketch for u of t minus 3? 0, 1, 2, 3. From 3 onwards, the magnitude of the signal is 1. So ut plus 2 minus ut minus 3. If you do the subtraction, then you will get minus 2 to 0. Correct. Minus 2 to 2. Minus 2 to 2. Here 1, here 0. 1 minus 0, 1. Up to 2. Okay. From 3 onwards, magnitude 1. Here also magnitude 1. So 1 minus 1, 0. So minus 2 to 3, the magnitude is 1. This is the given x of t. For this kind of signal, you do the sketch first. From the sketch, identify what is the magnitude of x of t and from where to where the signal is exist. Right? Now the integration limit would become minus 2 to 3. X of t magnitude is 1. E power minus j omega t into dt. So integrate this signal and substitute your limits. That's your result. So e power minus j omega t divided by minus j omega. Minus 2 to 3. 1 divided by minus j omega is a constant, take outside. So e power minus 3j omega minus e power minus into minus plus. So plus 2j omega. Sorry. So okay. U of t plus t minus u of t minus 3. E power minus 3 term is there now. So this is the result for u of t plus 2 minus u of t minus 3. Okay. Only for this term we have fine, but e power minus 3t is there. Sorry, I missed that term. So x of t equal to this term become 1. This term become 1 from minus 2 to 3, right? But e power minus 3t, one more term is available. So e power minus 3t dot 1 into e power minus j omega t into dt. So minus 2 to 3 e power minus t take outside. So you will get 3 plus j omega into d. So e power minus 3 plus j omega t divided by minus 3 plus j omega. Substitute your integration limit minus 2 to 3. So 1 divided by minus of 3 plus j omega. Take outside. Now substitute e power minus 3 plus j omega 3 and minus into minus plus. So e power 3 plus j omega 2. Or again, if you want to simplify, you can do it. Just multiply 3 inside. So the result for this given signal x of j omega equal to minus is there. If you multiply minus inside, then 1 divided by 3 plus j omega e power 2 times of 3, 6 plus 2 j omega minus e power uh, minus 9 plus 3 j omega. So this is the result. So we are discussing a different kind of problem. E power minus 80 uses standard formula. Then del of t formula, u of t formula, signum function formula. Apart from this, if a signal mixed with some elementary signals like this, then how to find the integration limit? Then sketch the signal carefully and solve the problem. Next, two important problems. These problems are very, very important. Find the Fourier transform of a rectangular pulse shown in figure. Find the continuous time Fourier transform or Fourier transform. Find the Fourier transform of rectangular pulse shown in figure. If this signal not given in the question paper also, you have to draw the rectangular signal carefully. Rectangular pulse. Next problem, triangular pulse. T is represented by pi of t by tau. From minus tau by 2 to plus tau by 2. The magnitude of this rectangular pulse is 1. Okay, so this is the signal sketch. If this is not given also, remember how to draw this standard rectangular pulse format. Okay, if this tau become 1, then it is pi of t from minus 0.5 to plus 0.5. But for finding Fourier transform purpose, we always refer the standard format of the rectangular pulse. Minus tau by 2 to tau by 2. The value of the signal is 1, which is represented by pi of t by tau. Okay. So pi of t by tau. We'll consider x of t. Magnitude 1 from minus tau by 2 to tau by 2. 0 otherwise. Okay. Now it's very simple. You identify the integration limit. for this signal directly. So x of j omega equal to integration minus tau by 2 to tau by 2. What is magnitude of the signal? 1. E power minus j omega t into dt. Okay, integrate e power minus j omega t divided by minus j omega. You substitute minus tau by 2 to tau by 2 and simplify the result and write down. Okay. So e power minus j omega tau by 2. I'm taking minus 1 by j omega outside. At last we will multiply. E power minus j omega tau by 2. Then minus e power minus into minus plus e power plus j omega tau by 2. So if you multiply minus inside, so 1 by j omega e power j omega tau by 2 minus e power minus j omega tau by 2. So do you remember the formula sin theta? E power j theta, sorry, 2j sin theta equal to e power minus j theta minus e power minus j theta. Or sin theta equal to e power j theta minus e power minus j theta divided by 2j. Okay, so replace this particular term by the sine function. 1 divided by j omega 2j sin omega tau by 2. So j will be cancelled. Okay. So x of j omega result 2 by omega sin omega tau by 2. Or further, this particular equation can be represented by sinc function. What is sinc function? Sin theta by theta. Normalized sinc function sin pi theta by theta. Okay. Sinc function equal to sin theta by theta. So sin omega tau by 2 is readily available. Sin omega tau by 2. So I need omega tau by 2 in the denominator also. Okay, omega is there. Omega divided by 2 also is there, but tau is not there. So multiply tau in the numerator denominator. Now this both the equation is correct, right? This equation is same as this equation. Because tau will be cancelled. Omega, this 2 will come on top. So 2 by omega sin omega tau by 2. Why I am modifying this? To write the result in terms of sinc function. So tau sinc function omega tau by 2. So this is the Fourier transform of a rectangular pulse. Please remember this answer. This answer is very important. Okay. Using Fourier transform properties, we will solve some problem. There we are going to directly write this answer. Fourier transform of a rectangular pulse, standard format. X of j omega equal to tau sinc function of omega tau by 2. So what is tau function? Tau value? Know this. This point to this point. This is minus tau by 2 to plus tau by 2. It's very important problem. Simple problem only. But if you have to do the integration very carefully, and the final answer should be written in the form of sinc function. Next important problem. Find continuous time Fourier transform of CTFT. CTFT of Triangular pulse. Triangular pulse shown in figure. Or if the triangular pulse is not provided in the question paper also, like half wave rectifier in Fourier series, you have to draw the signal carefully. So half wave rectifier output, full wave rectifier output, rectangular pulse, triangular pulse. So this signal sketch you must know clearly. So rectangular pulse. Del of t by tau. Representation is del of t by tau. 0, tau by 2, minus tau by 2. So from minus tau by 2 to 0, increasing slope. 0 to plus tau by 2, decreasing slope. At this point, the magnitude is 1. So this is a standard format for a triangular pulse. Sorry, yeah. Okay. For this signal, you have to find the Fourier transform answer. So previous signal, it's a rectangular. The magnitude of the signal is constant. So minus tau by 2 to tau by 2, x of t magnitude 1. It's very simple. But this problem, minus tau by 2 to 0, it is an increasing slope. The slope is like this. 0 to tau by 2, the slope is like this. So we cannot do the integration in a single step. First, we have to write down x of t from minus tau by 2 to 0. And 0 to tau by 2, what is the result? So in Fourier series, I taught you one simple format, y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. X represent the variable t here, y represent the variable x of t. Let's say this is the x of t in this particular problem. So this point x1 comma y1, this point x2 comma y2, and substitute. Find your x of t. And 0 to tau by 2. At this time, this point is x1 comma y1, this point is x2 comma y2. Substitute in this formula, you will get the expression for x of t. Okay. Or if it is possible to remember the del function x of t equal to, that is del of t by tau, the result is 1 plus 2t by tau from minus tau by 2 to 0, or 1 minus 2t divided by tau from 0 to tau by 2. Okay. If you follow this procedure, you will get this result. So it involves time consuming process. So I can directly write this expression, no problem. You can directly write your del of t by tau function. Okay. 1 plus 2t by tau. This interval. 1 minus 2t by tau during this interval. Okay. As some at the time of examination, let assume you forget this expression. No issue. With this simple concept, you can able to write your x of t expression between these two intervals. So now Fourier transform, little bit lengthy, but if we follow the steps, it's easy only. Minus tau by 2 to 0. Minus tau by 2 to 0, x of t is what? 1 plus 2t by tau. This is x of t into e power minus j omega t as per the formula dt plus 0 to tau by 2 1 minus 2t by tau e power minus j omega t into dt. Right? Now you apply the UV formula directly. It's your wish only. Either you can divide again this 1 plus 2t by this term into 2 term and this term into 2 and do it. Otherwise, if you're capable, then you can do it direct integration, UV formula. So we may consider this part is u and this part is v. Similarly, this part is u, this part is v. So what is integration UV formula? U integration v, and substitute this limit minus the integration of u dash integration v. So x of j omega u 1 plus 2t by tau 1 plus 2t by tau u integration of v e power minus j omega t divided by minus j omega limit minus tau by 2 to 0. I'm doing the first part now. Then minus the integration of minus tau by 2 to 0 u dash. You differentiate this term. One is a constant, so 0. So 2 by tau 2 by tau u dash integration v e power minus j omega t divided by minus j omega dt. Okay, so this is the result for first one. Similarly, second step 1 minus 2t by tau. Okay, plus 1 minus 2t by tau. This term u integration v. So e power minus j omega t e power minus j omega t divided by minus j omega. So limit there 0 to tau by 2. So minus the integration of 0 to tau by 2 u dash. So one constant. Here you will get minus 2 by tau. This term. Okay. U dash. U dash completed. Then integration v. E power minus j omega t divided by minus j omega dt. Okay. Now again do the integration. This step. So minus, shall I make this minus is plus, right? Here this minus will be cancelled. Okay. So in the next step 1 plus 2t by tau e power minus j omega t divided by minus j omega. Limit minus tau by 2 to 0 plus 2 by tau e power minus j omega t divided by j omega minus j omega. J square minus 1, this minus will be cancelled. So you will get omega square. So minus tau by 2 to 0. Okay, for this particular term. e power minus j omega t divided by minus j omega. So j square minus 1, this minus will be cancelled. You'll get omega plus 1 minus 2t by tau e power minus j omega t divided by minus j omega.
వెయిట్ చేసావరా?
Please mute your mic. Roll number 118. I think yesterday also same person. Roll number 118.
ఎస్ సార్.
Mute your mic.
నో సారీ.
Okay. So 1 minus 2t by tau, 0 to tau by 2. So minus 2 by tau. I'll take 2 by tau outside. Now e power minus j omega t divided by j omega. So that you will get omega square. So what is the limit? 0 to tau by 2. Okay. Then if you substitute the limit carefully and solve it, you will get the final result. Okay. So we'll continue the same problem in the next class. I think time up. In unit 3 particularly, Fourier series Fourier transform, it involves a lot of integrations.